Okay, folks, so here's today. So yesterday we started working on volume by revolution yesterday. We did the disk method yesterday, and we did just the disk method via axis revolution. Today we're going to add in the washer method and just any horizontal axis. So like yesterday, we're going to start off in a Desmos activity. Yeah.
I'm confused by these lessons. Like, was the integral thing not enough for you? Like, why do you need to have another way to find the area under the curve?
Oh.
Like, why is that necessary?
Because this chapter is all about applications of integrals. And not only does it find area, but we can use it to find volume.
That's why I like to know about it.
So three-dimensional derivatives.
Shut up, Tyler.
Yes, ish. In Calc 3, we started talking about double and triple integrals.
Whoa.
Yeah.
Physics is like it's just simple, very simple calculus.
When it's algebra based, yeah. But even that, like the calculus based stuff isn't terrible.
I should have just changed.
No, like most of our problems, at least that we're doing, we can do in algebra. But like some of them, it helps to know like radians. That's literally it's just radians.
Radius. I don't know.
All right, folks, go to Desmos classroom.
I'm gonna be right in.
No, you're not my name. Are you really? Well, you're gonna be the one that picks stuff.
Evelyn, did you get my email yesterday?
Yes.
Okay, so make sure you click on that link so you get enrolled into the thing.
Hey, how did we get our cool names yesterday on the Desmos thing? That was
Oh, I anonymize you?
Don't do that. Can you not do that?
no, do
No,
it
it's
again.
fine.
I generally do that just because if you know you're going to be anonymized, people are more honest and share deeper thoughts.
Oh, well, I was the one that got it. I'll tell you why I got everything wrong yesterday, because I thought
I
the
saw
cylinder,
that.
I thought the cylinder was like tall and skinny, not short and fat. So I was doing everything backwards.
That's okay. That's why I want to point that out. We I wonder why this
Because
was.
I thought the bases were parallel to the x-axis, not the y. So I was like, you get a rectangle, and it was like circle, and I was like, what? So then for the area, I said 60, because 12 times 5 is 60.
That's fine. It's all good.
25 pi, and I was like,
Basic, and my basic way of thinking
I
about
don't
basic
know what
problems helps me. They were just like,
All right.
yeah.
Yeah.
So please get to Desmos classroom. We're going to work on the first 3 slides first.
Oh my God, last year, Ryan Waldner and I were Courtney and Kim Kardashian.
I still have the picture of the two of you on one of my.
Do you really?
Yeah, I do.
Do people wonder, like,
They do wonder, but then no one asked. So
why?
because we were virtual, I think for that one.
Oh.
Yeah.
Man, that was a good time.
And unless it was last semester, unless it was my 6th-hour class, nobody said anything ever.
Oh no.
Like my 6th hour, every now and then they got me off track a couple times, which is awesome. But then, I mean, when you get off track for a 25-minute lesson, all of a sudden 5 minutes is 20% of class, and you've lost everything. So.
You know, hey, Nathan Shimon is in my literary festival hot money to sing my song "Twinkle Twinkle Little Star." Because I'm not gonna sing it.
We don't have
No, you don't have to. But I would really like to hear it like on an MP3.
Oh my gosh, what's that website called? Fiverr? Is that what it is? You can like pay someone to sing it on there. Yes.
That's funny.
Isn't that what it's called?
Yeah, that's Fiverr with 2 R's.
Yeah, Fiverr. It's like a website you just pay people to do like random ass things. Pay someone to sing your song.
Cameo of, like, I don't know, like.
Oh, there we go. Oh,
You can get like impersonators to like say things at you.
Or just, go on Cameo and get celebrities.
Yeah, I was just gonna say, like, get, like,
Wait, that's smart. Do that.
Lil Wayne doing the dinosaur song.
Yeah.
Evelyn, did you find that email for me?
I did. Yeah, I just.
It won't open. Click that link. That's okay. Now let me check over here. Just a moment, Dan. You're already in. You just have to go sign in to Google. Or just go back to Desmos or student.desmos.com. Log in with Google. And it should show up.
Are we still anonymous?
Not at the moment.
Yes. I'm getting along.
Is that working?
Yeah, I
Evan?
got it.
You got it? Okay. So that was the one from yesterday, but what that should have done is put you in the classroom, so you should have,
Yep.
okay.
So I know how to identify this one. I do not know how to write this double integral.
It's a single integral.
Oh, this is a single?
Yeah.
I don't even know if it's.
So is this red line, is that one,
It's our butt.
there's two
So,
lines here, right?
Yeah.
Yeah, wait, what?
so what you're seeing on the third slide and second and third slide is the region from the first slide rotated around the line y equals 4.
Oh, okay, I gotcha.
Yeah, we kind of got a, what's the word? A piecemeal start to this.
Okay, I was.
But that's fair. The real big thing I want to make sure you did is read the first slide and picked an option for slide 2. And once you got that an option for slide 2, move on to slide 3 and start writing what you think the integral might be. And we'll do it together, but I wanted to see what your thoughts are first.
Mr. Ross, what's my fancy name?
What's your fancy name? I haven't given you one yet.
Wait, you make the names?
No, it's just anonymized. And they're all like mathematicians.
I was curious. I told my dad about that. I was going, you use the Desmos name. He goes, yeah, sometimes. I go, what's up with those names? He goes, they're on mathematicians test. And I was like, geez, I want some math.
Oh, they were?
Yeah.
Yeah, when you anonymize in Desmos, they have.
You mean you don't know whoever? And I go, no, I don't know that person.
No, we don't. It would be. I could spend more time on stuff like that and then just.
Math teachers, y'all are weird.
I think we're fine.
Yeah.
It's true.
My eyes are red.
That's awesome. That's awesome, Megan.
I'm tired.
I'm exhausted.
I'm so, I worked Monday, Tuesday, Thursday, Friday, and then it's Uncle Breakfast Wednesday. I'm really not doing well.
Same. I'm just like mentally exhausted. Like I can't think.
Yeah.
All right. I'm gonna give you about 30 more seconds to get your ideas in there, and then we're gonna look at it together.
I think it's like I don't have any tests today. So
I
it's
do.
kinda-
I do.
With what?
AP Bio.
Fine.
Who else is in that class? You're in? I'm nervous for it.
I'm not ready.
I didn't
I thought during the fire drill there
me.
was
I have no
wondering
idea
if
what's
you
going
could
on.
not-
I can't study. It's a lot of just like the
That was,
problems.
I
And the problems are
know.
easy, but like I make stupid mistakes on them all the
No.
time.
I still
don't
understand
chi-squares.
Like,
So I just plug in the stuff.
Oh.
Yeah.
All right. So I want to take a moment and kind of talk about this and try to figure this out.
Charles Hermite.
How do I know my name?
You should be able to look up the corner. I'll tell you.
I'm Charles Hermite.
Defeats the point of anonymous, but I get you.
Vanessa clearly doesn't want to be anonymous today.
Clearly not.
I bold them my wrong answers. Okay?
To make the integral again, to start making the integral with the math type, start typing int, and the integral will pop up for you. All right. So I want to look at slide 2 real quick.
My names are so funny. I can't help it.
Well, it's just because you're not used to them. That's why. So this is the region that we're rotating around y equals 4. Okay, this is the region. Okay, so it goes around like this. So your question, the question presented to you is, what's the radius of each of these like cross sections, which are circles? Well, so we have some guesses going in through.
No, this isn't looking good for me.
It's okay.
What's her name?
Charles.
Yeah. So
Oh no.
don't change any answers right now because just wait. Because when I show you the answer key,
Oh, wait.
Tessa, you were right.
that's why I said just wait.
I'm
Now-
so smart.
So let's talk about it. F of x minus g of x seems fine, and so does g of x minus f of x. I want to point out why g of x minus f of x is the correct answer here and not f of x minus g of x, because that makes sense. It should be that. Because if we go back to this original thing, this length isn't g of x minus f of x. It's f of x. Oh, hold up. Did they just screw that up?
Oh, I thought I was so
No,
smart.
he screwed that up.
I thought I was so smart.
G of x minus f of x. Yeah, it is g of x minus f of x.
Yes.
It is.
Oh my God.
I got confused there.
You know,
Because the red line is f of x. The blue line is g of x. This distance, most people correctly assume the fact that it's something minus something. Okay, that's good. That's important. In this case, it was g of x minus f of x. x. And that the reason we're picking g of x minus f of x is because that's what the original region looked like. Okay? Because that's how we can define it from the original region to make it look that way. So we're saying the radius of this thing is g of x minus f of x. That's the one we're going to use. If we do it the other way, we'll get a negative answer.
Oh, so then I got this one too.
Well, the reason people pick that one is because you see f of x minus g of x. You just kind of looked up top and assumed that the order didn't
If you
matter.
chose the other one, would you get a negative answer or would you just get an infinity?
You should get a negative answer.
Really?
Yep.
Because wouldn't it be above the blue line then in that case and in between the red lines?
No, it'll just give you a negative answer
Oh,
because you're doing it in opposite order.
Are people changing their answers? I think mine's broken.
You can change your answer.
Oh, mine is.
All right. So let's do this volume together. Let's make it bigger so you can all see it. So we want to start hitting that integral. And again, we want to figure out what the bounds are. Now, the shape of these are discs, right? They're just solid discs. So we know it's going to be like pi. Do you want me to put the pi inside the integral or outside?
Oh, okay. It goes on the outside.
Yeah, you can put it on the outside or the inside, it doesn't matter. I just like putting it on the outside because I do. So then what I'm going to do is I'm going to do the radius squared dx. Now, what was the radius that we just said on the previous slide? G of x minus f of x.
Oh.
So what I'm going to do is put parentheses and do g of x, which is 4 minus f of x, which was e to the x minus x, which is going to be plus x. Well, that was,
That's not right.
there you go. It should look like that.
I really feel.
Why is it a plus here instead of a minus?
Oh, because it's, you subtract and then it, yeah.
Because we subtracted, it flips the sign there. So like if I was going to show a step before that, what you could do is throw a parenthesis there and then make that negative.
Do we have to do it like, do we keep it like that?
You could keep it like this. So when we were doing that yesterday's thing, when you're doing some of those by hand, those simpler ones, I want you to try to do some of those by hand. Whenever we do something slightly more complicated like this, I don't expect you to do these ones by hand. I need you to show me the setup is the most important part. But by the way, we're not done because we don't have our bounds yet.
Negative 3.981 and 1.749.
All right, let me try that again. Negative 3.
981. Oh, I always write them backwards. Which do you put? Is the biggest one always the one that goes on the top?
The lower bound where you start is on the bottom and where you go to is on the top.
Why I always mess that up?
And what did you say this other one was? Oh,
1.749.
okay. 1.749.
Yeah. And,
Boom.
oh, yeah. Sure.
So that's how that should look. Now this is still just a washer. Or I'm sorry, this is a disc because it's a solid thing. There's no holes in it. It's just all the cross sections are discs. So we find the area of a disc and then we integrate the area of the disc from the bounds of the region that made those discs. All right. You can hit submit. You don't have to, but you should just because it's fun. All right. So now what we're going to do, I'm going to stop pacing you. And I want you to start looking at this one and give me a response to number 4. Actually, I'm going to pace you again because I don't want you moving on from that yet. So tell me this. Oh, I'm on the slide. How will this all look different from the others when you have looked at it? What will its cross sections look like? So if I want to revolve this around the x-axis, so here's the x-axis right here. What are the cross sections going to look like? So type in what you think it should be. Type in what you think it should be. Don't say it out loud. Type in what you think it should be.
The cross section of the perpendicular perpendicular cross sections to X, right?
Yeah, so like I take this, I rotate it around to make a solid.
Yep.
It's gonna be cylindrical-ish. What are the perpendicular cross sections gonna look like?
I definitely got this wrong,
I've definitely.
but I'm not sure. on my-
But that's why I want you to just put it in there so I can find out what people have said.
I'm not pretty sure.
Well, I'm sorry.
Please, I want you to type in whatever you have because
Okay.
I want to,
I'm not changing.
Okay,
don't change it, just put in what you have. The most important thing is that you're sharing your thoughts. And take a guess.
Are you why did you do all caps?
My
Oh,
caps lock was on. Oh.
All right, let's take a look. So again, we're gonna be cutting it this way. So we have triangle, washer, a hole. There will only be one cross section. That's a good question. There will be a circle with a cutout of a circle in it. That's fair. Donuts. There will be a hole. A cylinder with a hole in it. I have no idea, but it might be a circle. Yep.
Notice this plural, see what I did? Because there's gonna be more than one cross section.
why are you
So-
sharing your name?
Yes, Gene.
That's the whole
Anyways,
thing.
so yes, this is going to have, so if we rotate this around, we're gonna get what are called washers. A circle with a circle cut out of it. Or a donut if you want to think about it that way. Just donuts are more three-dimensional. So that's why we use a washer, because washers technically are three-dimensional, but basically two-dimensional. All right, that's what we call them washers. So thinking of calling them washers,
Oh, got that wrong.
go to 5. That's okay. You put some thoughts in there, and that's what I wanted.
A circle with a smaller circle cut out.
Yep.
Someone's answer, that's pretty good.
I thought there were some good answers there. So here's what I'd like you to do next. Tell me what you think that, or like, what should the equation for the area of this washer be? Again, it's a circle with a smaller circle cut out. What's the area formula for the shaded region? Take a moment and try to come up with that for me.
This is too obvious to me, right?
What's the area is pi r squared?
Yep.
I know, it's like, my
Then you
legs.
have to do that in circumference, right?
Why is it? Am I being dumb?
No.
But it's like two different circumferences.
Yeah, make sure you're using a different R, because there's a big R and a little
Yes,
R.
That, yeah, that I understand.
He's not letting me type with a small
Why just take small or?
Are you sure?
What was it?
Make sure your cap locks aren't on.
R. Yeah, it's that.
My caps lock around for a hot minute, right?
Otherwise, if you can't change the size of the R, put R1, R2.
I'm feeling good about this.
All right.
I'm feeling good about my answer.
Oh, yeah, you should.
Watch me get miserably wrong.
All right. Let's share out what we got.
I don't.
I don't.
I'm going to summarize, see how many of them are the same. So it is pi capital R squared minus pi little r
Is it
squared.
really?
Yeah.
Oh, good.
So the bottom two, they had the right idea, but that's only for, this one's only for the outside circle.
Yeah,
This is for the inside circle.
yeah, I wasn't finished yet.
That's okay. You can finish putting in right now. I'm just pointing it out just to say what those are from. But good, that works. So that's how we're going to set up the integral for this, by the way. We just have a cross section that has a different area formula than a disk. A disk was basically the area formula of a circle. A washer just is a circle minus a circle. Now, a way we could generalize this, notice how these both have a pi in it. I'm going to just factor a pi out of that and put a pi out front. Yeah. So, boom. So I want you to try using that idea that it's the big radius minus the outer radius minus the inner radius. See if you can write me let me try that again. Write me a function that would give me the area of any of these washer cross sections.
It's what I said, gone too far.
Okay, well, let's do it together then. So we said generally, and I'm going to factor a pi out, that it was r squared
So is this just putting the g of x minus f of x
Into the
into
equation,
the
right?
equation with?
So it would just be 4 minus square root of x squared, so x. Just 4 minus x.
Yeah. Because our outer function is g, right up here.
Yep.
Our inner function is f. So you just, again, replace those with, what'd you say, 4 and x?
Yeah, right.
Oh, geez, didn't go far enough. Oh, We could do that. And that's the simplified version of that. Again, for our purposes, it's totally fine to just have like 2 squared.
Okay, great.
Square root. And it's also fine to just have it like this too.
Oh, I like the integral sign.
That's okay. Right now we're just doing this part. Then we're going to add the integral in the next slide. So this is fine, or the simplified version is fine. The reason I like this one is just because it emphasizes the different radii. That's all. When you simplify it from there, that's fine. It's probably easier to actually compute and look at, but that's how I'd approach it. But cool. So either one is fine, doesn't matter. Let's hit this last one. So let's actually find the volume now. Well, let's just take the equation that we wrote in the previous one. So I'm going to do an integral first. I think the bounds of this are going to be 0 to 4. Oh, type int. As soon as you type int, it'll pop up. I'm going to go back and type pi out front.
Not even home on Tuesday, so it's not really gonna.
Why does is it okay if you don't put the pi sign in front of the integral?
Yeah.
Okay.
Sorry, see the value of the integral right now?
Yep.
I'm going to take the pi out and put it right here.
Oh, okay.
It doesn't make a difference. The reason I advocate for putting it out front is that when you're actually doing it by hand, it's one less thing to look at. And so it's less confusing because it's one less thing to look at.
Right. I like putting it up, because it's easier to distribute it to their.
And it looks clean.
When they want to get to the end, you have like a fraction, you just put the pi on the fraction.
Yeah. So that's kind of our new thing today, is looking at things that have cross sections that are washers. Okay. And we can kind of keep looking at it this way. And I have a couple, and we're going to keep using this region in a couple different ways. And I'm going to connect it back to good old representative rectangle, which I think is still just, I think it's a funny joke. It's funny in my head, but I'm not sure it's super great. So here's kind of what the region looks like. Like when you take that region we just worked with, the 2 in the square root of x, and rotate it, it kind of looks like this. Again, it's like kind of a weird looking cup. Yeah. Well, I mean, this is from the side. I have a perspective where I can change it so it doesn't look that way, but it still looks weird. Aeroplane. So if we draw a representative rectangle, what rep rectangle helps us do is identify what are the different radii here. So we're revolving around y equals 0. So my big radius is 2 here. My little radius is square root of x. So again, the width of my representative rectangles in terms of x. Again, I'm saying that because eventually next week we're going to look at, well, when it's not an x, how does that look? Yeah, we're going to look at that next week. The height of this rectangle is 2 minus square root of x, which is helpful, but it's also not as helpful here because we see the cross sections need to be washers. So I need to know what the big radius and the little radius are. So my big radius is 2, right? My little radius is square root of x. So if I plug that into this formula, and again, a and b was what, 0 and 4? I get that, which is what we just did on the slides. Again, in this one, I chose to put the pi inside because I don't know, I'm inconsistent AF. So before we move on, because I'm going to add just one more layer, pun intended, to this, what questions do you have at this point? Yeah.
It's probably three-dimensional.
I mean, this is technically already three-dimensional. But I'm not, no, we're still going to do washers.
Yeah, but it's with a single integral.
We are only doing single integrals in this class. You don't even get double integrals until Calc 3.
Oh, thank goodness.
All right. Now what I want to do is I want to revolve this region not around y equals 0, but y equals -2.
Oh, so,
Yeah, so it's just like bigger. And in fact, it's kind of like, yeah, it's just a bigger region, right? So-
The radius, the only thing that changes.
Yes, the radius is the only thing that changes. Let me say that one more time. The radius is the only thing that changes. So let's look and see how the radius does change. I'm going to still draw a representative rectangle because I think it's helpful to keep doing that. Again, big R isn't just this part. There's more to it now. As Christian pointed out, the radius is different. Both radii are different. And little r, I had put it in black so you can actually see it, is now not just this piece, but this whole piece down here. So again, thinking about rectangle, again, the width is still dx. The height of the rectangle is still 2 minus square root of x. That doesn't really help us in this part. That really matters mostly when we're doing discs. But big R is, the way I figured it out is I'm like, well, this is function 2, this is y equals 2, this is y equals -2. If I subtract them, that should give me the difference, which is the distance between them. So 2 minus -2 gives me 4. So big R is always 4. Little r is square root of x minus -2, which is +2.
So you got a constant in this one.
Yeah, there's an extra constant
That's nice.
like this. So when we revolve around something that isn't y equals 0, we're going to be adding or subtracting something or rearranging things a little bit. I'm going to show you what I mean in the next one. But before we move on to the next one, what questions do you have about what we did there? Again, the format is very similar. It's just that we have to keep thinking about what's the big radius, what's the little radius. And when I say that, the big radius means what's the outer radius, and the small radius is the inner radius. All right. What if we revolve around the line y equals 3? So we're going to revolve it the other way. So now instead of looking like kind of a smooth cylinder with something taken out of it, it's kind of like there's a smooth hole bored through it, and I don't know, it's like a cone with a hole in it.
you have to subtract from a circle with whatever the radius of like what it shifted is.
Well, now it's just gonna be the opposite. Now it's gonna be f of x minus g of x.
That is a big part of it. So before we had g of x minus f of x, now f of x is the outer radius and g of x is the inner radius. But then we also have to deal with this little piece here too. So let's see how that looks. Because again, now big radius is that,
Yes.
little radius is that. Again, the width and the actual height of the rectangle doesn't change, but this is the part that does. Oh, I thought I changed that. So big R is going to be 3 minus square root of x. See that distance here?
Mhm.
Because this whole distance here is 3. This distance is square root of x. I don't want either one of those. I want just this piece. So big R is 3 minus square root of x. Little r is 3 minus 2.
This actually makes good sense.
Plug it in. There it is.
Yeah, exactly. It's easier to think about. I have a picture to associate this with.
And if you go to this presentation, which I just added to the chapter 6 stuff, I have a Desmos calculator for this one and the previous day that actually will show you the animation of the revolution happening. This one is really slow in animation, just to let you know. All right. That's all I have for you. I have 3 questions today. Yeah, there's 3 questions today. Notice how whenever we did these, when I did those last 3 examples with you, I always had a picture. I always drew on the picture. You should too. When you're doing 13, 14, 27, and basically here on out, and really previous part, always draw your picture, always draw all over your picture. Okay? So virtual folks, kept you longer than expected, but have a wonderful day. Try hard, send questions. Otherwise, stick around and we'll answer more questions. So I offered this to the folks yesterday. Would you like me to start working on 13 with you?
Sure.
And then I'll post the picture on Schoologies or in the presentation so you can look at it. Where the heck's my pencil case?
Ate it.
There it is.
Did you say you ate it? Yeah, nice.
Son of a bitch.
Whoa, Mr. Last.
I so many like boundaries are not happening this year, so get wrecked.
Yeah, right.
Sorry, I just had to destroy.
Yup,
It's fine.
it's fine. All right, so we have 2 functions here in 13. We have y equals x squared and y equals 4x.
You should like that.
Yeah, I think so. Minus x. Yes, I should.
He's saying these words and I go,
Yeah.
that makes sense.
So we're going to revolve this region over 2 different lines. So I should sketch this first to see what the hell is this. See, x squared looks like this. And I'm going to relabel this as f of x. Relabel this as g of x.
Math teachers are OGs and X is so funny.
My g is like a horrible 9 also.
Your Y's are silly looking too.
Yeah, I changed the way I write x, y's, and z's when I was in physics. I like, nope, I'm losing too many things. So I spent the whole semester,
Learning how to write.
yeah, basically intentionally changing the way I wrote stuff, so it became second nature. Let's see, 4x minus x squared, I think it's gonna be facing this way as a vertex at 0 and positive 4.
So you're just drawing one singular graph and then you're gonna like figure how it revolves around
Different lines.
the different axes? Okay.
Can someone graph that on a calculator for me to make sure it looks
Yeah, that
better?
looks good.
Okay, so looking at this, they both have the intersection here at 0, 0, so that's helpful. I need to know what this intersection point is. My guess is at 2.
I can look.
I think it's 2, 4.
2, 5. I'm guessing.
Oh,
How do you do that? You go to the calc, is that what it is, the calc button, and then you go, intersect 5. Yes. 2, 4.
oh, hot.
Dang.
I appreciate the competing opinion though. Reagan. All right, so this is the region right here that we're caring about. So part A, we're revolving around the x-axis, which is right here. So again, I'm going to draw my little rough rectangle. Help me think about stuff. So for x equals 0, or y equals 0, my outer radius is g of x. My inner radius right here is going to be f of x.
How do you know that? Like,
Because
just
the-
by-
Whatever on the top.
Yeah, because I'm revolving around this, I was
Oh,
going to try to revolve it
So
around.
those coordinates.
I got you.
That's why.
And that's why I always write it down then afterwards. Also, I should mention width. The width right here, it's in x. So I'm doing dx. So let's set this up. I'm going to throw the pi up front because don't tell me what to do.
Yeah, you get grandpa's.
All right, so the first one I'm gonna put is big R squared. So g of x minus little r squared. And yeah, we can plug that in calculator and find out what the answer is.
You can?
Is it doable to find that by hand? Sure. At some point, like I really just wanted you to do part 1 by hand because I didn't think those were too bad. This one you don't have to do by hand.
Oh.
So see if I can beat you to it. Aha, probably.
Probably.
No, stop, I'm gonna, like, my brain is hurting a lot right now. I'm
Because
sending. Oh, I can do F1 and F2,
Oh yeah, you could. You'll probably beat me if you do
but I
that
don't remember how to do it.
too. Ooh,
Okay, let's see.
I'm taking a shortcut calling X to the 4th.
Math. Oh, this is looking at you guys.
I got it.
I got this back.
Where do you find the numbers? The letters, I mean?
Oh, the variables?
Yeah.
There's a button that says VARS. It's pretty close to the down arrow.
Then Y window, one function.
Ooh, Mr. Last upgraded this year. He's got a fancy graphing one.
Fancy driving.
Yeah.
That's
Oh, is it your phone?
That's just my phone.
Oh, it looks like a.
It's an emulator.
Oh,
Well, that's nice.
But I did upgrade the
Y2.
ROM I was using.
okay.
I was just using like a 83 plus ROM.
Yeah.
Now I'm using the 84 plus
Yeah, I was
with
gonna say,
color,
that's like
so
the
now it looks like
fancy-
the rechargeable ones.
Kind of like what Tessa has.
Yep.
in the order.
I'm working.
And I figured out I could change the color of the faceplate, so I'm like fancy AF.
Do it like how your mood is for that day.
It's always red.
Whoa.
Oh, no.
Uh-oh.
No, it's just because red is my favorite.
Okay.
Oh, okay.
I was like, why are you angry?
I mean, I think generally as an adult, you're pretty much always angry about something.
That's excellent.
Yeah.
Love that.
So then these, we just, I mean, it's calculus, I'm assuming we don't need units. but it's just
33.51.
Do not put units.
Really?
Yeah, unless there's a context to the problem, don't put units.
Just straight number?
Straight up.
That boggles my mind.
Yeah, because at some point in your education, we're like, no naked numbers, no naked
Yeah,
numbers.
because you're like, what are you talking about? 10 monkeys? No, shut up. Like, that's so dumb.
In pre-calc, we really tried to like nitpick that and like remember when we were doing like area and curve approximating area.
Ew, I hated
The
it.
but area wasn't always something squared. Sometimes it's just miles.
Yeah, that's true.
And that, I mean, calculus is the reason why we don't just put we're okay with any numbers.
Right.
Like it's a fine. not to
I'm
have
fine
numbers.
with making numbers,
Yeah,
I just
same.
gotta
I love
know
making
when I can
numbers.
use making numbers.
It's kind of fun to just keep saying naked numbers a lot.
Okay, so when you rotate it on y equals
6.
6, how does that change the equation again?
All right, well let's draw it in, figure it out.
Well, because y equals 6 is above the 4 in the one, it means that you're gonna switch your f of x and g of x. And then you're also gonna have a different inside variable, or
Okay.
radius. not
Oh,
variable.
so don't you have to like subtract, do you have to add 2 to
It helps it
both
draw
parts
at
of the
least in the
equation
next.
now?
Yeah, definitely draw this. So.
Yeah, it really-
I'm gonna doodle on this one and like draw more. So let's see. Here's big R.
Uh-huh.
And it's again this distance. This distance is 6. This distance is f of x. So I want 6 minus f of x for big R. Oh, I'm gonna make sure to put width. Again, my width is in dx, so we're good. So big R is 6 minus f of x, which was, I'm just gonna write 6 minus f of x right now. Because that's big R right there. Again, that's why I draw on rough rectangle to think about what end of rough rectangle is the outer radius, what's part's the inner
And
radius.
then inner r is gonna be a constant, which is gonna be,
And then is it 6 minus g of x for the small one?
And then now that we have the width, the bigger radius, or the outer radius and the inner radius, we just plug into our formula and we're good to go.
So can we just, okay.
By the way, so you were, Tess, you were talking about how do you know where to go, or like where to put the different numbers? Notice how I draw my integral. I start at the bottom and go to the top.
Oh.
It's an intentional choice. It's automatic at this point, but it's intentional because I'm always starting down here at the lower bound and ending at the upper bound.
Okay, so.
But these bounds are still the same.
So I can do that in calculator.
So-
It's gonna take me a while, but I'm gonna figure it out.
Yes, that is.
The R squared minus, big R.
Mhm. No, I was smart, I would go back and. Hopefully I actually know what I'm doing.
Do you get the same answer?
Shouldn't.
Why did I get the same answer?
That's a great question.
Why did I get the same answer? I didn't do this. Maybe the pie got messed up? I'll just wait to see what you get and I'll see what I get.
That seems good. I have one to my friends, like close over.
Okay.
Yeah, I got something different. I got almost double that. Actually, it was double that, which is very odd. So I got 67.02.
Can you see what I did then?
Sure.
I don't know what I did wrong.
Scary.
Also, we should check the answer in the back of the book before.
There's what? There's answers in the back of this.
Are you
Oh my
dumb?
God, Tyler.
I know, I didn't know
I
that.
could not.
Literally
You didn't use the
odds.
Slater that
I
much,
didn't
did you know
know
their
You didn't even know about Slater either!
Are you serious?
All the odds have answers.
No, oh my.
Wow.
How does he
You're not know about any of this.
Yeah, right? This is how I've been surviving.
You know what? I'm much more impressed.
I've been struggling extremely hard.
I'm very proud of all the struggle you've done.
Yeah.
You've grown so much, but
Zero- silly
Tears have
gooses
been
for
shed,
that.
I'll have you know.
I figure like since pre-calc had answers in the back of the book that you're probably
But
checking to see
look at
if
this
some
book,
of those-
does this look like a nice friendly book with answers in the back?
Mr.
Also
Last,
true.
Mr. Last, can you look at my calculator?
Oh,
I'm
yeah,
a
yeah.
person of assumptions.
That's very fair. Hold on, 13. It's double. Yeah, well, it should be double the answer.
Yeah, it is. I don't know what I did wrong. I don't know what I typed in wrong.
I'm not a cheater, you guys.
Cause like those things, I swear in the 6 minus.
Oh, the square needs to go on the other side of front.
I just used my.
Because it's 6 minus
Yeah,
5.
right.
Not 6 minus 5.
That'll do y'all.
Yep, that'll do it.
That'll get you real good.
Every time. Have a wonderful weekend, folks.
I'm just gonna write 2 times 33.51 for my.
Okay. I can live with that. I mean, you're showing the work, and if like the calculator part isn't working, we have time to practice.
From myself and Mr. Cruz, once again, please check your
I
email.
almost got it, but I didn't.
Why am I checking my email?
Adib, I'm sorry. I had an accident around the phone. Oh, I'm so slow right now. Oh my gosh. I'm really nervous.
Wait, what?
Why am I nervous about finding probability? It was like 1 of 4. I'm like 20.
Oh, hot damn.
What? It's so-
Pizza Friday.
If you're a Walgreens member, you can sign up as an essential worker to receive your first COVID vaccine as of Monday.
Mr. Wise, you're gonna get vaccinated?
Yeah,
Oh my gosh, wait, that's exciting.
dude, that is. That's why I'm like, why am I getting an announcement right now? Bro, thanks, y'all as well. Unless you want to sit at tables and no one else. probably only 3 of you today. Does anyone else show up, or is it just the 2 of you? Oh, look, there we go. Yeah, there's only 3 of you. The other 2 are not here today.